This whole setup is for synchronous generator. It has a DC motor of 3 HP, alternator or synchronous motor of 5 HP. The whole connections are provided over this panel. This is made by LabVision Technologies, Ujjain, and supplied to Engineering College situated at Ratlam. So we have a synchronous motor and a DC motor. The connections are like that. These 4 wires represents the field and armature windings of DC motor. This 6 wire represents the field winding for 2. 1 is neutral and 3 are the phases over which the generation will take place. Okay. Now coming to the panel, it has voltmeter, ammeter for AC, voltmeter, ammeter for DC. This whole setup belongs to generator side. This whole setup belongs to DC motor side. This whole setup belongs to synchronizing side. Okay. Now this is voltmeter and this is ammeter for AC calculation. For DC calculation we had provided a ammeter and a voltmeter so that we can calculate this field binding readings. What field we have provided from there to this point we can calculate through this ampere meter and through this voltmeter. Now this 6 terminal belongs to alternator. This 4 terminal belongs to what we call load. This is neutral, this is R, this is Y, this is B, this is field negative and this is field positive. Okay. Now coming to the DC motor side. Ampere meter, voltmeter, ampere meter, voltmeter, this all are DC voltmeter and ampere meter. That is called moving coil type. We have provided 4 terminals for DC motor and these 4 terminals belongs to the power supply. LED shows the indication for power is on or not. This connection will be made short circuited from this field to this field to this, and this armature to this, and this armature to this, so that the actual main power will be connected to this DC motor. After that we will take the readings for voltage and ampere as per the requirement. Now coming to the generator side. In generator side we have 6 terminals for alternator, 4 terminals for load, and all this terminal belongs to ampere meter and voltmeter. This 3 LED will show the generation of the synchronous machine. Okay. Now coming to the synchronizing part. As the setup will be in working, after that when we use these 2 phases and put it over this frequency meter, it will show the frequency related to the generation. That is, if frequency of generation is 49 Hz, then this 49, the part will blink like this. If frequency is 50 Hz, then this part will blink up and down simultaneously. Okay. Now after that this will be connected against the phase. Now after that we have 3 terminals over here which shows us RYB, the 3 phases of generation. These 3 phases will be connected to this phase sequencer. If it moves in this direction, then the generation and this 3 terminals shows RYB. If it is moving in this direction, then these 3 terminals are not in phase, or we can say they are out of phase. So we have to manipulate the connections right like this, this or this, so that the real phase comes like Y, B and R, Y, B. In this way we can done synchronizing with respect to infinite bus bar, because infinite bus bar has a frequency of 50 Hz, the grid has frequency of 50 Hz, and the sequence RYB. If the sequence and frequency matches each other, that means our generation is synchronized to the main line. Thank you.